this video lecture, we are going to talk about ionic nomenclature. Specifically, we're going to learn how to name compounds when given their formula. Here's a general overview of the types of compounds that you will be asked to name in this unit. There are a couple different types of ionic compounds, and then we are going to talk a little bit more in depth about acids and bases. But really, acids and bases are just types of ionic compounds. They're special types, but they're still just ionic compounds. And we're going to learn how to name those in this unit. You will be responsible for knowing how to name all of these types of ionic compounds. When we are naming these compounds, the first question that we are always going to ask ourselves is, what kind of compound do we have? So if we look at the formula and we see Na, you should find Na on your periodic table, and then based on its location, you should decide whether that element is a metal, nonmetal, polyatomic ion, etc. Na is a metal. Then N represents nitrogen, that's a nonmetal. So if we have a metal and a nonmetal, then overall we've got an ionic compound. Once we know that we have an ionic compound, we know that we need to follow the rules for naming ionic compounds. First things first, when we name ionic compounds, we start with the name of the cation. Na is the cation. So when you found Na on your periodic table, you will see that the name is sodium. Sodium is in group 1. And since it's in group 1, we don't need to worry about including any Roman numerals because every group 1 metal has a fixed charge. So then we just look at the nonmetal. The nonmetal is nitrogen. And when we name ionic compounds, we actually are going to change the ending of the nonmetal, the anion. We're going to change the ending of the anion from nitrogen. We're going to cut it off, and we're actually going to say nitride. We're going to change the ending of the anion to an IDE ending. The cation, sodium, that just stays how it is. We don't have to mess with that. But we do have to change the ending of the anion. So our name becomes sodium nitride. We don't need to worry about prefixes. That's very important. We don't need to worry about prefixes in ionic naming. So when you're naming, don't even worry about the little 3 subscripts. It does not come into play in this example. All right, let's move on to FeO. Let's figure out the name for FeO. First, we always have to figure out what kind of compound do we have. Well, we see Fe. We find it on our periodic table. We know that Fe is a metal. Specifically, it's a metal in the transition metals area. That's going to come into play later on. Then O stands for oxygen, which is a nonmetal. So if we've got a metal and a nonmetal, overall we have an ionic compound. Then we follow the rules for naming ionic compounds. First, we write the name of the cation, which is iron. You should never guess what the name is. You should find the symbol on your periodic table, and then in that box, it will tell you what the name is. Do not guess. Iron, though, is in the transition metal area. It is a metal that does not have a fixed charge. In fact, it has a variable charge. What that means is that iron can have multiple different charges. And how do we figure that out? Well, we need to start with the piece that we do know the charge of. So in our formula, we need to look at this oxygen, this O. Oxygen will almost always form a 2- charge. If we know that oxygen has a 2- charge, and we know that all compounds are neutral, remember all compounds are neutral, if oxygen has a 2- charge, then we know we have to have a 2+ charge in order to balance out our overall charge and end up with a neutral compound. If we need to have a 2+ charge that can only come from the iron. So how we write that in the formula is we include a little 2, Roman numeral. Then we move on to the anion, which is the O, and we change the ending of that one. It's originally oxygen. We're going to cut it off right here at the ox. We're going to turn that into oxide. So the name for our compound is actually iron 2 oxide. Oxygenide sounds sort of weird. Oxygide sounds even weirder, so that's why we leave it at oxide. There are some anions that just you have interesting naming endings that you just need to become familiar with. Oxide is one of those. CaSO4. First things first, what kind of compound are we dealing with? Well, Ca is a metal. SO4, you see it's in parentheses there. The parentheses is sort of a hint that I'm talking about a polyatomic ion. However, the parentheses don't necessarily need to be there. So you should be able to recognize SO4 as a polyatomic ion. If we have a metal and a polyatomic ion, then overall we have an ionic compound. So we follow the rules for naming ionic compounds. We start with the name of the metal, which is calcium. Calcium. And then actually with polyatomic ions, this bit's pretty easy. We just write the name of the polyatomic ion. Don't even have to change the ending. I'm just going to write calcium sulfate. And that's done. That's my work for this problem. All of my work is right here, just trying to figure out what kind of compound I have. Next up, H2S. Here's the deal. When you see this H out in front, all that tells you is that you have an acid present. So you're going to go ahead and take this over here and you're going to write acid. That is the only contribution of the hydrogen, just that it says acid in the name. For the rest of the name, we need to look at this anion, this S. S is going to have the name sulfide. And if we look at our naming rules for acids, IDE endings go to hydroic. Ate to ic, ite to us, ide to hydroic. And then we're just going to fill in that middle bit. Hydro sulfuric acid. Again, this is one of those weird examples where maybe you thought to write hydrosulfic acid, and really that's fine, because if we look at our stem over here, we would cut it off at the SULF, sulf. But some things we just name because they sound good, and so this is going to be hydrosulfuric acid. Moving on to the next example, we have HNO3. Again, we see this H, and all it tells us to do is write acid at the end. That's all it tells us to do. We don't even have to worry about anything else with the hydrogen. Then to figure out the name, we just look at the polyatomic ion. You'll notice here, I did not put parentheses around HNO3, around the NO3. I could have written parentheses there, but I did not. It's up to you to be able to recognize NO3 as a polyatomic ion. Okay, but what is the name of this polyatomic ion? Nitrate. Nitrate has an ATE ending. ATE endings go to an ic ending. Ate to ic, ite plus ide to hydroic. So if I change the ending, I'm going to write nitric acid. My next example, I'm just going to do AlOH3. Again, my first step, I need to figure out what kind of compound I'm talking about here. So I look at Al, and I'm like, okay, that's a metal. OH3, that's a polyatomic ion. But this is a specific type of ionic compound. OH tells me that I have a base. And we're going to name them just as we name other ionic compounds. So when we do name these ionic compounds, we always just write the name of the cation first. So that's aluminum. Aluminum has a fixed charge. Remember, all elements in groups 1, 2, aluminum, zinc, and silver have fixed charges. Aluminum has a fixed charge, so I don't need to worry about Roman numerals. And then I provide the name of the polyatomic ion, which is hydroxide. Hydroxide, that tells me I've got a base. Everything lines up, and that's aluminum hydroxide. This was a video about nomenclature, going from the formula and writing the name. There is a second video that goes from the name to the formula, so definitely check that one out as well.